is 1 upon x minus 1 upon 1 minus x. We have to obtain the Maclaurin series of this. So what we need to expand, we need to find out the derivative of the given function. What are the derivative of the given function? The derivative of the given function, we need f dash x. And the first derivative will be 1 minus x raised to the power minus 1 times minus 1. This is the first derivative. We can write down this first derivative as minus 1 or minus 1 minus x raised to the power minus 2. This is equal to what? This is equal to 1 upon 1 minus x square. 1 upon 1 minus x whole square. And now we can find out the another derivative by what? F double dash x. We can differentiate it by this function. Minus 1 into minus 2. 1 minus x raised to the power minus 3. How many minus sign we do have? Minus 1, I think so. 1 minus x raised to the power minus 1, 1 is less than that, and this minus 1 comes from the power, and one more minus sign we should have here, because the derivative of minus x is minus 1. So we have one more minus 1 here. And if I multiply these two minus signs, I have a plus sign here. And if we have a plus sign here, then minus 2 will comes out, and minus 1 minus x raised to the power minus 3 times minus 1 we have one more minus 1 here. So this is equal to 2 times 1 minus x minus 3. This can be written as 2 upon 1 minus x whole cube. Now third derivative will be what? Third derivative will be 2 times minus 3 and 1 minus x raised to the power minus 4, and one more minus sign we have here, because internal derivative of 1 minus x is minus 1. So that can also be written as 2 into 3. Can I write down it as 3 factorial divided by 1 minus x raised to the power 4 and so on. So in the same way, if we proceed in the same way, so what will be the kth derivative? If I am interested in the kth derivative, f k x. So this is equal to what? This is equal to k factorial divided by 1 minus x raised to the power what? Can anyone of you tell me what will be the power?
k plus 1.
K plus 1. The reason is, if we have third derivative, so we have 1 minus x raised to the power 4. If we have second derivative, we have 1 minus x raised to the power 3. If we have first derivative, we have 1 minus x raised to the power 2. And all the terms are positive. If we have second derivative here, so in denominator, we have 2 factorial here. This is 2. 2 can be written as 2 factorial. If we have third derivative here, it is 3 factorial because 2 into minus 3 and minus 1. So this is 3 factorial. So similarly, in the kth derivative, we have k factorial divided by 1 minus x raised to the power k plus 1. Now we have to plug in all the values of the derivatives into Maclaurin series. So what the Maclaurin series is, in the Maclaurin series we have fx can be written as f0 plus f dash 0 divided by 1 factorial and x raised to the power what? X raised to the power 0. No, x raised to the power 1. Then we have f double dash 0 divided by 2 factorial and x raised to the power 2 and so on. If I am introducing the kth term, then the kth derivative at 0 divided by k factorial x raised to the power k plus so on. If we are introducing it as an infinite series until the last we have. So what about f0? f0 is 1. Because if we put 0 in place of x, this will becomes 1 minus 1 upon 1 minus 0. So this is 1. Plus, what about f dash 0? F dash 0 means we have to plug in the 0 here. If we put the 0 here, this will become 1 minus 1 upon 0 whole square. This is again 1. So we can write down at x raised to the power 1. And f double dash 0, if we put 0 in place of x, what it will be? This will becomes x square and f double dash 0, we have 2 factorial over there. In denominator, we have 2 factorial. So that can be written as only x square. And in the same way, we have to proceed. The 1 plus x square and so on. So this will be the expansion of 1 upon 1 minus x. So you can see the solution here. If you can see the solution that the derivatives are shown, and after computing the derivatives, we have substituted x is equal to 0 into these derivatives, and the final term will be shown there. So you can see that if we put the x is equal to 0, then the all derivatives becomes 1. Derivative will not become 1, derivative will becomes number of times we are differentiating and the factorial of that in the product. Because if you have k factorial in numerator and k factorial in denominator, it will be cancelled out. The k factorial in numerator and k factorial in denominator will cancel out each other. So you can see that 1 upon 1 minus x, a function is 1. and f dash is equal to 1. This is equal to 2. This is equal to 6. 6 means what? 6 means the 3 factorial. So whatever we have in denominator in the form of factorial, the same number we have in the form of factorial in numerator, that will be cancelled out. So 1 upon 1 minus x can be represented by 1 plus x square, x cube, and so on. If anyone is interested to find out the algorithm for this, so I already explained you how can we write down the algorithm for this 1 upon 1 minus x. So it's quite simple. So we have to just show whether by the for loop or by the while loop. If I am representing it by a for loop, so this can be represented as for I 1 to n with no step, because all powers are required. There is no need of step 1 or step 2. Then we have initially the value of series as 1, and we have to input the value of x, input x. So input x means what? User has to input the value of x, and the sum, initial sum, will be the 0. Then s is equal to s plus what? S is equal to s plus can I write down the x here? Is this correct? S is equal to s plus x. So I think it will not correct. Here we have to write down s is equal to s plus x raised to the power I. So when the value of I is 1, so this will be the x raised to the power 1. The x raised to the power 1 will be added. Now it is the end of loop. You can determine the, if I run the algorithm, the value of x, suppose value of s is 1, and the value of I will be what? Initially the value of I will be 1. The first term will becomes what? S is equal to s plus x raised to the power I. X raised to the power I means x raised to the power 1. So what is the initial value of s? Initial value of s is 1. So if I add 1 and x, so this will becomes 1 plus x. And 1 plus x will be the value of what? This will be stored in the s again. So the previous value of s will be removed, and the new value of s will be the 1 plus x. Now at the moment I have these two terms added. If I move to the next value of I, then the next value of I will be the 2, because 1 with the 1 increment. Then the next statement will becomes what? Next statement will become the value of s, and one more term is added, and what that term is? X raised to the power I. Now the value of I is 2, so this is equal to x raised to the power 2. The previous value of s is what? Previous value of s is 1 plus x, and one more value of x square is added in that. The new value of s becomes 1 plus x square. This is the new term. And then value of I will be 3. One more term will be added here, and that term will be what? That term will be x cube. because the value of I is 3, the x cube will be added. So if I add x cube in the value of s, the previous value of s is what? These three terms are there in the previous values of s. These are the terms. And so on. If I move to the next term, it will be the x cube will be added. So this is the way of writing the expansions into the algorithms. And finally, one step will be there after completing the loop, and what that term will be? Return what? Return s. The value of s is returned. So this is the algorithm. This compute the complete value of. So if I extend this to the 5 terms, then the loop will be ended x raised to the power 5. If the value of n is 8, then the loop will be ended to the 8 number of terms we have in that in the expansion. So this is the way of writing a Maclaurin series. In this series, we have to values of I are to be generated. As I told you, this is the sequence that we have to generate. We have to generate the sequence with the increment of 1. With the increment of 1, so we can choose these two numbers and drag this handle. After selecting these two numbers and dragging the handle, this will generate a series. Suppose I am interested in 10 terms only. So if you are interested in 10 terms only, so we have I is equal to 1 to 10. Then we have the values of x. So I am just inserting one thing here. This is x. And user has to input the value of x. So the value of x, suppose I am giving any number here. Suppose 0.5 is the value of x. So we need what? We need sum, a term. Individual terms will be there. Individual terms will be what? X test. In the first term, we have 1. In the second term, what we have? X raised to the power 1. In the third term, what we have? X raised to the power 2. In the next term, what we have? X raised to the power 3. So we have what? We have x formula. We have to write down the formula here. X, the value of x. We have to focus on the value of x. Multiply by, not multiply by, power by. Power by what? Power by I. This is I. So this is the formula, but we have to freeze the value of B1. Because if I change and copy the formula to the cells beneath the cells, then B1, the value of B1 will also be changed. This will become the value of B2, value of B3. So I don't want to change the value of B1 because this is the value of X, which is fixed. So we have to press F4. We have to press F4 because by pressing F4, this will becomes freezed. So $B, $1 means the value of B1 will not be changed if I copy the formula to the down cells. So now this is the correct value. Now this is x square. What is 0.25? 0.25 is nothing. It is 0.5 whole square. What is this? 0.125. It is nothing. It is 0.5 raised to the power 3. So if one more thing we can do, just double click here. If I double click here, then it will automatically be copied to the relevant range. So there are the two ways to copy. One is to drag the handle, and another way is to double click on the dot. If I double click on the dot, the formula will be copied itself to the specified range in the column number 1. So these are the terms, but this is not the correct way. This is not the correct series. The series can be obtained by the sum, because we have first term in the series as 1. Second term will be what? Second term will be x. Third term will be what? X square upon x square. Next term will be x cube, and so on. So in the same way, we have to proceed to the last term. So what is 1? This is 1, first term. And what is x? I think so. We do not have the value of x here. So we should have one x should we should have x here. So it is important. The x, I should have x here. So otherwise it will not be the correct sequence. The one will be added separately. So I am inserting one row here. I am inserting one row here. In that row, I am introducing one thing. What thing I am introducing? Which is necessary to introduce here to complete the series. And that thing is x. It will be the x raised to the power 2. This should be the x raised to the power 1. So this formula is to be copied here. Now, this is the, and I should have 1 here. The first term will be 1, then this is. The second term will be x raised to the power. So I can write down one more thing here just to create a similarity in the formula. I am placing the 0 here and copying the same formula here. So you can see that it is not 1, it is x raised to the power 1. I am just updating this expression here. So this is what, this is nothing, this is x raised to the power 0. And this is x raised to the power 1. This is x raised to the power 2. This is x raised to the power 3, and so on. So what I did just 0 here and 1, 2 up to 10. This is what, this is x raised to the power 0. So I just copy the formula one time. It is x raised to the power 0, x raised to the power 1, x raised to the power 2, and so on. Now in the second column, I need sum, because my interest is not in the individual terms. My interest is in the series, because the final answer will be the series. Now I'm computing the sum or the series. Sum can be written as the first term will be the as it is. I should have. I can copy the first term here. I'm not copying the first term here because it should be a fixed term. It is 1. Now I have to add this and this. These two numbers are to be added. So why I have to define the formula here. This is equal to this plus this, 1.5. Then I have to add this and this. These two numbers are to be added because it has the total of 2 terms. And this is the third term. If I add these two, then the total of 3 terms I have. So just copy this formula here. So now what is 1.75? 1.75 is the 1.5 plus 0.25. So these 2 terms will be added. This is 1.75. In the same way, you have to proceed next. So you can see that 1.9. So what will be the expression? What will be the sequence? The sequence is 1, 1.5. 1.5 is the sum of these two. I'm just implementing it here. This is this, and this will be added. If we add these two, we have this answer. If I add this and this, I have this answer, and so on. If I have this and this, these two numbers are added. I can calculate the error. I can calculate the error if error. Error will be what? Error will be the difference, true error. If I am interested in the true error, then what will be the true value? To find out the true value, I should have the left hand side of this. What will be the left hand side of this? The left hand side of this was 1 upon 1 minus x. This was the left hand side, as you can see in the presentation. 1 upon fx. What was the fx? You can see the fx is what? Fx is 1 upon 1 minus x. So this is the left hand side and this is the right hand side. So I wrote the left hand side there. Now true value can be obtained as true value. True value is equal to what? 1 upon, I should not write it. 1 upon, now it is in the bracket, 1 upon 1 minus x. So 1 minus x, x is 0 0.5. In this example, I am using x as 0 0.5, 0 0.5. So what will be the value? The value 2. So we can see that we are going to converging towards 2. You can see that it is 1, 1.5, 1.75. We are going to 1.999. If I introduce the more term here, so you can see that we are moving towards and towards to the 2. Next value 1.9995 and next value and next value. So you can see that the error will be reduced every time. I'm just removing it from here, Control X, and placing it here. And I am introducing more term here. So you can see that every time I am introducing one more term, I am closer to the 2. This is 2. So at how many iteration I have the 0 error. At the 18th iteration, I have the 0 error because the true value is 2 and the approximate solution will also be producing a value which is same as. So if someone is interested to calculate this value by actual formula, so you can implement because the analytic solution is available. But in this example, you can find out then approximate solution by applying the Maclaurin series. So what will be the errors? The error can be computed as we are interested in the absolute error, not on the relative error. So we are interested in the absolute error. The absolute error will be calculated by the function ABS. What the function ABS does? Function ABS calculate the absolute error or the absolute value. Means if the value is negative, then it becomes positive. So to sum, which is the approximate value, and the true value is 2. So minus the true value. This is the true value. And I should have to fix the true value because we will not have to change the true value. So the absolute cell reference is needed. The function F4. F4 button is to be pressed to keep it. So now the error is 1 because it is 1 and it is 2, the error is 1. Now it is 1.5, it is 2, the error is 0.5. And now next time error will be 0.25 because it is 1.75, it is 2. So 1.75 minus 2 minus 0.25 due to the absolute sign, I have the positive number here. In the same way, you have to proceed to the term by term. So you can see that the error is converges, error to 0. And here we have the value of 0. I can extend the size, and it is in the exponent terms. So 0.0000 something we have. And you can see it is approximately 0, but if I fix the decimal points, then it is exactly 0, because the numbers are 2 is there or over there. So this is the way of writing a series, and